Hello everyone, today is day 52 of solving a LeetCode problem every day, and today I'm going to be solving permutation in string. This is a little bit of a trickier problem, but let's get straight into it. So, given two strings S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. All a permutation is a rearrangement of all the characters of a string. So in other words, return true if S1's permutation is a substring of S2. So, for example, here we have the input string AB for S1, and S2 we have EIDBAOOO. And the reason the output is true is because S1 can be rearranged to BA, and we have a BA right here. So BA is a substring, or the permutation BA is indeed included in S2. Now here, for example, 2, our S1 is going to be AB and our output is going to be false. And the reason why is nowhere in the string do we have a permutation of S1. So the way I'm going to be solving this problem is through using the sliding window technique. So we're going to create two arrays that are going to count up all the characters in each string. I'm going to be using an array instead of a hash map just because a hash map in this case is going to make our solution a little less efficient. So an array is just going to make more sense for our problem. So we're going to initially create these two arrays, and we're going to start with AB and EI, so just the first two characters in the string. And the reason why is that our window size is going to be fixed throughout our algorithm. It's always going to be 2 characters wide. And the reason why is because all permutations of S1 are going to be of length 2, so we don't have to actually change our window size. And then pretty much what we're going to do is we're going to shift this window throughout the second string. So we're going to start with EI, then ID, and B, then DB, and then BA. And then we're going to update our count array to match the state of where this window currently is. And if at any time the matches in this string equals the matches in this string, so if the two arrays match up to each other, then in that case we can return true. Otherwise, if it never matches up, we can return false. So the first thing I'm going to do is initialize these count arrays. We're going to have S1 count and S2 count. And these are just going to be two arrays of length 26 with each character initialized with a 0 first. The next thing we're going to do is actually fill up these arrays. So we're going to loop through the range of S1. And since I'm looping through the range of S1 here, I do have to validate the fact that S2 is at least the length of S1. So what I'm going to say is if length of S2 is less than, so if length of S2 is less than length of S1, then we can just return false. Actually, wait, this might have to be a less than or equals. Yeah. Or no, sorry, if it's just less than, because we're returning false. So basically, this now protects us from an out of bounds exception here, since S2 is always at least going to be of length S1. And now what we can say is S1 count, then we're going to do ORD. And all OR does is just converts our characters to their, I forget what it's called, but it's like the encoding or whatever. So for example, like an A would be 96. So we're gonna grab S1I, so the current character at S1, and what we're gonna do is we're gonna subtract this by the encoding of A. And the reason why is, for example, if S1I was an A, this would be equal to 97 minus 97, which would give us index 0 in our count array, which would be representative of A. Or for example, if this was a B, this would be 98, and then this would be 97. 98 minus 97 is 1. So now we have 1. We're going to be accessing the first position in our array. Not our first position, but our second position in the array, and updating that. So pretty much this just keeps this it converts our current character to its like numerical position within the array. And what we're gonna do is just increment whatever is there by 1, and we're gonna do the same thing here, but with S2. So now we've created these two arrays, and they store the counts of up to the length of S1, many characters in the array. But now we actually have to do create the logic for, or actually not yet. What we need to do next is figure out what the matches are. And the reason why we're keeping track of matches is because if we don't keep track of matches, we're going to have to recalculate the matches within each iteration of moving our window. And for us to do that, it would take O of 26, right? Since there's 26 characters within each array, and we want to compare, we're going to have to perform 26 comparisons in between each count, or each count array. So we don't want to do that because that's going to bring up our algorithm to n squared. So what we instead want to do, or it's not going to be n squared, it's actually going to be like O times n, or O of 26n. So I guess it's still linear, but I mean, this is just going to make it more efficient. So we're going to say for I in range of 26, if S1 count I is equal to S2 count I, we're going to increment matches, and I actually do have to declare that variable too. So matches is equal to 0. So now we're keeping track of all of our matches. So for example, if we have, in this case, we would have AB and EI, our matches would be equal to, what would it be? It would be equal to 22, because the A, B, E's, and I's don't match in each array, so we'd have 22 matches. And the whole idea is if there are 26 total matches at any time, since we're going to be updating the counts, then we know that we found a permutation. So now let's get to that part. So we're going to say for R we're going to first declare our left pointer, and then we're going to say for R in range of S1 count, of length of S1 and length of S2. And what this does is now we begin looping through, so if we have A, B, and EI, we would start looping from D to the last O. So from index 0, 1, 2 to whatever that last index is. Because since we already processed the first two elements here and here, we don't need to do it all over again, so we can just skip that part. So if at any point our match is equal 26, we want to return true. And now we have to do two things. Since we're incrementing our R and incrementing our L each iteration, then we have to perform these updates to our S2 count. Our S1 count is never going to change, but our S2 count is going to change since we're updating our window every time. So we're going from EI to ID to DB. So we have to perform those updates. So we're going to grab the index, and this is just going to be like what index we need to currently update in our S2 array or S2 count array. And that's just going to be S2 of R. So we're going to start by updating our right pointer, and this we can just subtract the ord of A. So this gives us the index that we're looking at. And then what we're going to do is we're going to increment this count at that specific index, since we just have, so like since we're sliding right, if we're at EI, we're now at EID. So we want to include D in our count array. And we essentially have two possibilities now. So if we go from EI to EID, we either have the possibility of now having a new match, or we also have the possibility of having one less match, right? Because we go to EID, now D is either included in this S1 string or it's not. So what's going to happen here is we're going to say if S1 count, so the current character at that index, then we grab the value of how many of those characters exist. We want to compare that with what the value of this is now, and if those are equal, then we can increment matches. But then what we can also check to see is, since we're incrementing S2 count right here, what we can do is check to see if S1 count plus 1 is equal to S2 count now. And what this pretty much tells us, if this is true, would mean that before we incremented this right here, these were equal. So now they're no longer equal. So what we can do is just subtract the matches. Subtract 1 from the matches. Because, like, for example, if we maybe had like something like this, and then so we have this, maybe this is what our second array looks like. Let's say they're the exact same for now, and let's say now we come across another B, so B becomes 3 here. We can now see if S1 count for B, so S1 count for B plus 1 would be 3, and S2 count for B is now 3. So we now know that once we incremented this B right here, we lost the equality between the two. So now we know that an earlier match that we had is no longer a match, which is why we're subtracting 1 from the matches. And now we're just going to do the same thing, but for our left pointer. So we handled our right pointer here, but now we have to handle incrementing our left pointer. So we were at EI, then now we just added D, but now we need to remove this E. So we're going to recalculate this index, and the reason why is because we want to grab the left pointer instead of the right pointer now. So this gives us whatever index we want to work with in our array. And now we want to say S2 count index is -1, since we're removing the character now. Now if the S1 count index is equal to the S2 count index, we can increment matches. And then now we can do the opposite of what we did before. We can see if S1 count at index -1 is equal to S2 count of index, then we can subtract 1 for matches. Now the reason why this is the case here is because let's say we had the same thing from before. We had A1, B2, A1, and B2. And now let's say we slide our window and we want to remove a B. So we remove a B here. And now here we check if S1 count of index, let's say we're looking at B, subtracted by 1, so this turns into a 1, is equal to the S2 count at index. So is it equal to 1? It is. So here we saw that earlier this was a match, but it's not a match anymore because we subtracted 1 from the S2 count array. So here we're checking if this was 1 greater before, and since it was, we can decrement matches. So cool. And then finally, we just want to increment our left pointer. Then in the end, we can just return if matches is equal to 26. And it says invalid syntax. So it says at line 10, and it seems like we're forgetting a closing bracket here. If I run this again, accepted, submit it, accepted. So the time complexity of the solution is going to be O of n, and the reason why is that we're practically just iterating through each character in each string, and checking if matches is equal to 26. Like, since we're maintaining the amount of matches in this, like, through between each string, through our algorithm, we don't have to recalculate matches at any point. So these are all just constant time operations, which is why it's O of n. And then our space complexity is also going to be linear. I mean, technically it's linear, but it's also going to be constant because our arrays here are always going to be of size 26. That's never going to change, but it is technically going to be linear. So yeah, and so I guess your other option with this solution could have been maybe like using a hash map to keep track of the counts. And the reason why I didn't use a hash map is because with a hash map we'd have to recalculate these matches with every iteration. It's just much easier to do it with an array. So yeah, that's my solution for the day.